When installing plate steel over existing wooden floors, it's essential to address grounding and bonding to ensure electrical safety. Several codes and standards provide guidance on this matter. Article 250.118(6) of the National Electrical Code requires bonding of metallic items to the electrical grounding system if they are connected to the structure to metal paths are likely to become energized. There's an exception in Article 250.118 for metallic equipment connected to the grounding system through a rigid conduit. NFPA 70E, the Standard for Electrical Safety in the Workplace, Section 110.4, requires grounding and bonding of electrical equipment and metallic objects that could become energized. Section 110.46 specifically includes metal surfaces that are likely to become energized. IEEE Standard 1100, the Emerald Book, Section 4.43, requires bonding of all exposed non-current carrying metal parts of equipment to the grounding system. Based on these codes and industry best practices, are recommended approaches to bond the plate steel to the electrical grounding system. This can be achieved through several methods including welding, bolting, or using ground clamps. Install a ground rod or another suitable grounding electrode. The grounding electrode should be sized and installed according to the NEC requirements. Connect the ground rod to the electrical grounding system using a grounding conductor. An exception exists if the plate steel is isolated from the electrical grounding system and not likely to become energized, in which case bonding may not be necessary. However, this determination should be made by a qualified electrical professional. There are additional considerations to keep in mind. Ensure that the grounding system is properly designed and maintained. Inspect the grounding system periodically for damage or corrosion. Keep the grounding system away from flammable materials. Label the grounding system to avoid accidental disconnection or tampering. Following these recommendations helps ensure the plate steel is properly grounded and bonded, protecting workers and equipment. Now let's delve into the specifics of each step. Firstly, bonding the plate steel. The goal of bonding is to create a low impedance path for fault current to return to the source, allowing overcurrent protection devices to operate and clear the fault quickly. Welding the plate steel to a known ground is one method. Ensure the welding is performed by a qualified welder and that the weld provides a continuous and reliable electrical connection. Bolting can be used to bond the plate steel. Use appropriately sized bolts and ensure the surfaces are clean and free of corrosion. Apply a conductive joint compound to enhance the electrical connection. Brand clamps are another option for bonding. Select clamps that are listed for grounding and bonding purposes and are compatible with the materials being joined. Ensure the clamps are properly tightened and make good contact with the plate steel and the grounding conductor. Secondly, installing a ground rod or grounding electrode. The NEC specifies requirements for grounding electrodes in Article 250. A ground rod is a common type of grounding electrode. It should be at least 8 feet long and made of a suitable material such as copper or copper-clad steel. Drive the ground rod into the earth so that at least 8 feet is in contact with the soil. If rock bottom is encountered, the ground rod can be buried horizontally in a trench that is at least 30 inches deep. Other types of grounding electrodes include metal underground water pipes, metal frames of buildings, and concrete encased electrodes, often called UFA grounds. The choice of grounding electrode depends on site conditions and the specific requirements of the installation. Thirdly, connecting the ground rod to the electrical grounding system. Use a grounding conductor to connect the ground rod to the building's electrical grounding system. The grounding conductor should be sized according to NEC Table 250.122, based on the size of the overcurrent protection device protecting the circuit. The grounding conductor can be bare or insulated, and it must be protected from physical damage. Connect the grounding conductor to the ground rod using a listed connector suitable for direct burial. Connect the other end of the grounding conductor to the building's grounding system, typically at the main service disconnect. Fourthly, let's consider the exception where bonding may not be necessary. If the plate steel is isolated from the electrical grounding system and not likely to become energized, bonding may not be required. Isolation means there is no direct electrical connection between the plate steel and any grounded metal objects or electrical equipment. The likelihood of becoming energized depends on factors such as the proximity to electrical conductors, the presence of insulation, and the overall electrical environment. A qualified electrical professional should assess these factors to determine if bonding is necessary. Fifthly, proper design and maintenance of the grounding system. A well-designed grounding system is critical for electrical safety. The grounding system should be designed to provide a low impedance path for fault current to return to the source. This helps to ensure that overcurrent protection devices operate quickly and clear the fault, minimizing the risk of electric shock and equipment damage. Regular maintenance of the grounding system is also essential. Inspect the grounding connections for tightness and corrosion. Check the grounding conductors for damage or deterioration. Test the grounding electrode resistance to ensure it is within acceptable limits. Address any issues promptly to maintain the integrity of the grounding system. Sixthly, keeping the grounding system away from flammable materials. Grounding conductors and connections can become hot during a fault condition. It is important to keep the grounding system away from flammable materials to prevent fires. Do not run grounding conductors through areas where flammable liquids, gases, or dust are present. Use appropriate clearances and barriers to protect flammable materials from the heat generated by grounding conductors. Seventhly, labeling the grounding system. Labeling the grounding system helps to prevent accidental disconnection or tampering. Clearly identify all grounding conductors, connections, and electrodes. Use labels that are durable and resistant to environmental conditions. The label should indicate the purpose of the grounding system and any relevant warnings or instructions. This helps to ensure that only qualified personnel work on the grounding system and that it is properly maintained. In summary, properly grounding and bonding plate steel over wooden floors involves several key steps, including bonding the plate steel to the electrical grounding system using welding, bolting, or ground clamps. Installing a ground rod or other suitable grounding electrode, ensuring it is sized and installed according to NEC requirements. Connecting the ground rod to the electrical grounding system with a grounding conductor. Determining if an exception applies, where bonding may not be necessary if the plate steel is isolated and not likely to become energized, and ensuring this is determined by a qualified professional. Properly designing and maintaining the grounding system, inspecting it periodically for damage or corrosion. Keeping the grounding system away from flammable materials to prevent fire hazards. Labeling the grounding system to avoid accidental disconnection or tampering. These measures contribute to a safe electrical environment in the factory. The NEC, NFPA 70E, and IEE Standard 1100 provide detailed guidance on grounding and bonding requirements. Consulting these resources and working with qualified electrical professionals are essential for ensuring compliance and safety. Remember that electrical codes and standards are subject to change. Always refer to the latest edition of the NEC and other relevant standards for the most up-to-date requirements. Grounding and bonding are critical aspects of electrical safety. Proper implementation helps to protect workers and equipment from electrical hazards, ensuring a safe and productive work environment. Finally, consider the following hypothetical situation to further illustrate the importance of proper grounding and bonding. Imagine a scenario where the plate steel is not properly grounded. A fault occurs in a nearby piece of electrical equipment, and the fault current flows through the plate steel. Because the plate steel is not grounded, the fault current cannot return to the source, and the overcurrent protection device does not operate. The plate steel becomes energized, posing a significant electric shock hazard to anyone who comes into contact with it. In contrast, if the plate steel is properly grounded and bonded, the fault current would flow through the grounding system back to the source, causing the overcurrent protection device to operate and clear the fault quickly. This would prevent the plate steel from becoming energized and eliminate the electric shock hazard. This scenario underscores the importance of proper grounding and bonding in ensuring electrical safety. By following the recommendations outlined above and adhering to applicable codes and standards, you can create a safe and productive work environment. When dealing with electrical systems, always prioritize safety and consult with qualified professionals. Their expertise can help you navigate complex code requirements and ensure that your electrical systems are properly installed and maintained. Always remember to de-energize circuits before working on them, use appropriate personal protective equipment, and follow safe work practices. Electrical safety is everyone's responsibility, and by working together, we can create a safer work environment for all.